Alright, hello everyone, you're welcome to today's class. So in this class we're going to, like the title on our board says, okay, so we are going to be looking at solution to these exercises. We've been able to cover the first part of the exercises. If you've not seen the video, there is a playlist, okay, for all of them, and I would also attach the the link of the videos to the description of this one. Okay, so meanwhile, this is not the first part of the part 2. We've actually done from exercise 1 to 6. Okay, so you would also find it here. Although I've not published that yet, I'm going to publish it after this live section. Okay, so but I'm going to, in this particular live section, begin from exercise 7. All right, so being that I already pre-recorded exercise 1 to 6. Okay, so I'm going to bring the upload for that 1 to 6, and we would of course it will make up for where I am beginning now. Okay, so the number 7 says that we should resolve into partial fractions 6x raised to power 3 excuse me, plus 5x squared minus 7 all over. So here we have 3x. Okay, sorry, this should be squared here, up there, not okay. So you have squared there, and then this one is 3x squared minus 2x minus 1. And okay, so in the material there is a hint where we are told that this is equal to 2x plus 3, and then plus, okay, so this up is empty, so we have 3x squared minus 2x minus 1. Okay, so we have a job now, which is to find the value of what should be up here. Okay, and then always recall that, like I've always said, that I think this shouldn't be a square. Let's remove this. Okay, so that when it comes to simplifying or splitting a given fraction into its partial fractions, that one thing is important. There are about 5 different categories we can have, where you have in your denominator distinct linear denominators. Okay, so it can be distinct linear, it can be repeated linear, and it can be distinct quadratic, and you can have repeated quadratic. Okay, repeated quadratic. Okay, and then these are actually the 4 major classes that you can see, but then there is a 4th or a 5th one that can take any of these 4 forms. And what is that? When the numerator is of equal or greater degree than the denominator. Okay, so if the degree of the numerator is equal to the degree of the denominator, or is greater, then you now try to do one or two things first before resolving. And what is that thing that you would do? You first of all reduce it, because for us to have partial fractions, then the numerator must have a lesser degree than the denominator. Okay, and from what I can see here, if this definition gave us linear, then this should be 3 and not 2. So this one should be 3, and then let the other one come back as 2. Okay, so I think these are just typographical errors from the printers. Okay, so now let's quickly go on. So first of all, we need to get the remainder that will be on this. This thing actually means that, because the first thing, like I said, is that you need to divide this numerator by this, and when you do that division, you will get a whole part, then get a remainder, and over the remainder, it's just like you are dividing 7 by 3. You are going to get 2 whole number, then 1 over 3. So it's just the same thing as writing 2 plus 1 over 3. Okay, so which is exactly how we've written this. Okay, so the numerator here is now the remainder. So, and that's exactly what we are looking for here before we will now split that particular one into partial fractions. Okay, so let's go. So we are going to now apply division of polynomials, which we have always been, seeing on this channel. I've also handled that as a topic, of course, you can find it under polynomials, which I would also, describe in this video. I'll put in the link in the description. All right, so let's go on. From here now, we are going to have, of course, we divide using only this 3x squared. So if we divide this, we are going to get 2x. Okay, and 2x will now multiply everything, and then we'll check if there's a remainder. So let's do that. So if 2x multiplies 3x squared, we will get 6x cubed. Then again, 2x multiplying minus 2x will give us minus 4x squared. And finally, 2x multiplying minus 1 will give us minus 2x. Okay, so we will now look for our any remainder. So of course, if you subtract, this part will turn to 0, and then 5x squared minus 4 is going to give us 9x squared. Okay, so we will now remember that that's not the only subtraction. There is minus 2x here, and in the upper part of this expression, there is no x, so it's assumed that your x is 0. Okay, so that means you now do 0 minus 2x, which is going to give us plus 2x. Okay, so you now go again. So we use the same 3x squared to divide 9x squared, and that is going to give us 3. Okay, so you see that that's how this 2x plus 3 was gotten. Okay, so the 3 will multiply through again, so we will have 9x squared, and then 3 times minus 2x will be minus 6x, and 3 times minus 1 will give us minus 3. So we will drop down this 7, and of course it will be minus 7. So we will now try to subtract to check for remainder again, and that is going to give us, this will cancel out as 0, and 2x minus minus 6 will give us minus 8x, and minus 7 minus minus 3 will give us minus 4, because minus 7 minus minus 3 will be minus 7 plus 3, which will give us minus 4. Okay, and then you will now see that 3x squared can no longer divide 8x, and so that is how that is now going to form a remainder. So you see that this is the quotient that we have, which is exactly what they gave us here. So that's actually, that's 2x plus 3. So plus, so what will now be up here will now be this 8x minus 4 that we got here. All right, and that is over our 3x squared minus 2x minus 1. So that's the first part of the thing you are required to do. And after you've done that, they also require that you now finish up the partial fraction by now splitting this one into its partial fractions. Okay, now, and we can now continue with that. And to do that, we would need to change the denominator into its linear form. So we'll try to factorize this. Okay, so let's do that. We have 3x squared minus 2x minus 1. You know that for factorization, you will use your a to multiply your c, and that's going to give us minus 3. So we are looking for two numbers that will multiply to give minus 3, but will add to give us minus 2. And what are they? Minus 3 and plus 1. we'll do that. So we'll now use it to replace here. So we have 3x squared minus 3x, then plus 1x, which is just x, and then minus 1. Okay, so we will try to now create two brackets here, and then we factorize. 3x is common here, and this will give us only x minus 1. In this place only 1 is common, so you bring out 1, you have x minus 1. Remember we said that how you will know that your factorization is correct is that you will have two common brackets, and that's what we have achieved here. So we now gather the ones outside the bracket, and then the ones outside is 3x plus 1, and then you pick one inside the bracket, which is x minus 1. Okay, and so these are the two linear factors that we now need. So we will bring it down now. Okay, so I'm going to leave away these 2x plus 3 because it's like a whole part. So we are only going to deal with the remainder part. So, and the remainder part is 8x minus 4 all over the two linear factors that we just got now, which is 3x plus 1 into x minus 1. Right, so we will now start our partial fraction splitting. So since these are linear, so the numerator will be a all over, you can go with 3x plus 1 first, then plus b all over, you will now go with x minus 1. Of course, remember we have always said that for partial fractions, when the denominator is linear, then the numerator should be a constant. But if the denominator is quadratic, the numerator will be linear. So the implication is that your numerator is always 1. The degree of the numerator is always 1 less than that of the denominator. Okay, so let's go. Our job now is to get the value of a and b, and it's an easy task to do. So we pick our LCM, 3x plus 1 multiplied by x minus 1. Okay, so if we divide, 3x will cancel to give us x minus 1, and that will multiply our a, plus x minus 1 will cancel to give us 3x plus 1, and that will multiply our b. And we are done. Take away the common denominators. Let me come over this way. So if you do that, you are now going to have that 8x minus 4 is equal to a into x minus 1, and then plus b into 3x plus 1. Okay, so our job now is to get a and b, and to do that we can try to eliminate b or a. So in this case I want to eliminate a first because that would work with a whole number. So, and what number is that? 1. If I substitute my x as 1, a will turn to 0. So if we do that across, you're going to have 8 times 1, which is 8 minus 4, equal to, this one will turn to 0. Here you now have 1 times 3, which is 3 plus 1, 4, and that will give you 4b. So 8 minus 4 is 4, equal to 4b. Therefore, our b is equal to 1 if you divide both sides by 4. Beautiful. So the other job is to now get a, and to do that we can now meanwhile always note that the one of the things you will do to give you the value that you will substitute and it will eliminate whatever is to pick the bracket and equate it to 0. Like here, if you pick x minus 1 and equate to 0, you will get x as 1. So in the same way, if I pick that 3x plus 1 and equate to 0, of course 1 will come over here to be 3x equal to minus 1, and so x will give me minus 1 over 3. Okay, so that means if I now let my x, let's do that. So if I let my x be equal to minus 1 over 3, that will help me eliminate b. Okay, so quickly let's go. Okay, let me bring this down a little. So we are substituting here. So we are going to have 8 into minus 1 over 3, and that is minus 4, is equal to, on the right hand side you would have a into minus 1 over 3 minus 1. Then if you put minus 1 over 3 here, it will turn to 0, so no need writing it. So this will now give minus 8 over 3, then minus 4 over 1 is equal to, this one is, now if you join these two, that's minus 1 over 3 minus 1, that's going to give you minus 1 whole number 1 over 3, which you can change to improper fraction as minus 4 over 3. Beautiful. Okay, so okay, so what's that going to lead us to? So that means we are going to have minus 4 over 3a on the right hand side. Okay, meanwhile you can actually decide to clear this fraction. There is a over 3 here, so multiply through by 3. You know, if you notice, you've always seen me do that. Whenever there's a fraction, I try to clear it, because without fractions you work more efficiently. So if I remove these fractions here by multiplying through by 3, this one will give me minus 8, then this one times 3 is minus 12, equal to this one times 3, it will clear the fraction, so I'll have minus 4a. So minus 8 minus 12 is minus 20, equal to minus 4a. So you divide both sides. Of course, minus minus will cancel out. Then if you divide both sides by 4, you will get that our a is equal to 5. Wow, this is very beautiful. Okay, so you have our a as 5 and our b as 4. Is that what I got? No, b as 1. Okay, so you can then come back and substitute into the fraction. Okay, so if you substitute into the fraction, that's this fraction here, so that's going to give us our a is 5. So that means that our 8x minus 4 all over 3x plus 1 into x minus 1 is equal to a, which is 5 all over 3x plus 1 plus b, which is 1 all over x minus 1. And this is the partial fraction that you are required to produce, right? So I believe that is very clear and beautiful enough. So we move over to the next exercise, which is exercise 8, and amazingly it's still another partial fraction. Okay, so you know that there's a progression in this exercise booklet which journeyed from one topic to another. So in each topic we got a few exercises. So for partial fractions, we are seeing from number 6, number 7, number 8, and number 9. And then from number 10, they got into permutation and combination. So we are going to get there. So let's progress. So for number 8, we are also asked to resolve 17x minus 53 all over x squared minus 2x minus 15 into partial fractions. And in this case, there is no hint at all. Okay, and I love questions like this where there is no hint. It allows you to think. Okay, so should we go on now? Yes, we should. So like I said, you can see the denominator is quadratic, so we would need to resolve it into linear factors. So let me bring it up here. So we have x squared minus 2x minus 15. Okay, so and here your c is minus 15 and your a is 1. So if you multiply the two, you still have minus 15. So we are looking for two numbers that their product will be minus 15 and their sum will be minus 2. And what are they? Help me now. What do we have? Okay, of course, you look for the factors of 15 that will do that. I think 5 and 3 will do it. So we now need to know which one will be negative and which one will be positive. And of course, the bigger one should be negative since the sum should be negative. Yeah, minus 5 plus 3 will be minus 2, and their product will give you minus 15. That's correct. Okay, so and since the coefficient of x squared is 1, remember the approach I always tell you to use. So you are going to have open two brackets and put in your x in both of them. And so now carry these two factors that you got, attach minus 5 here and attach plus 3 here, and you are done. So bring the same under as the denominator here. So you will have 17x minus 53 all over x minus 5 multiplied by x plus 3, and that is the two linear denominators that you want, which will now give you the two fractions that you will just be looking for their numerator. So I'm splitting it into a all over x minus 5 plus b all over x plus 3, and my job now is to get the value of a and that of b. Is that something we can do? And the answer is yes. We have always been doing that. So you take our LCM like usual. LCM is still x minus 5 into x plus 3, and then of course x minus 5 will cancel. You have a into x plus 3, and then plus b will go into x minus 5. This is nice. Of course, the denominators will disappear. Let's come over this side. So we just have 17x minus 53 is now equal to a into x plus 3 and then plus b into x minus 5. And these ones are whole numbers, so should be easy for us to work with. So to eliminate b, we just make our x 5. So let x be equal to 5, and we are done. 17 multiplied by 5 will give us what? 85. You should learn to do some of these multiplications inside your head. How did I get 85? I have 17 times 5. I'll multiply the 10 inside that 17 by 5, and it will give me 50. I will now multiply the 7 by 5. It will give me 35. I just told you exactly what I did. You know, you can always do this to help yourself be faster in exams. Okay, and this is minus 53 equal to, if I put my x as 5 here, I will have 8a, because this will give me 5 plus 3, which is 8, multiplied by a, and that is 8a. And then this one here will turn to 0. So I will now go ahead. So 85 minus 53 will give us 32, and that's equal to 8a, and therefore our a alone is equal to 32 over 8, which is equal to 4. All right, so we have the value for a now. Let's quickly run for that of b, and to get our b we need to eliminate a. So to eliminate a, we can make our x to be negative 3, and of course that will help us. So we multiply 17 by minus 3, that will give us minus 51. The same thing, multiply the 10 by 3, that's minus 30. Multiply the 7 by minus 3, that's minus 21. Join the two of them, you get minus 51 minus 53 now, which is this one, is equal to, on the right hand side, a will turn to 0. So if you put minus 3 here, you'll get minus 3 minus 5, which will be minus 8b. Okay, so if we get that, so we'll join these two, which will give us minus 104, and that's equal to minus 8b. So of course minus will cancel minus, and my b will be equal to 104 over 8. So you can help me to divide that. 104 over 8, of course 2 can go to give us 52 all over 4. 2 can go again to give us 26 all over 2, and finally you will get 13. So our b is 13. Okay, and you are done. Just come here and replace here with your a, which is 4, and then replace this one with your b, which is 13, and that is what is required, to complete your partial fractions. So it means that our 17x minus 53 all over, there we had x minus 5 into x plus 3 is equal to a we got as 4 all over x minus 5 plus b we got as 13 all over x plus 3. Okay, and that is the solution to that problem. All right, so we move on. So that's for number 8. So we go straight away to number 9, which is like I said, another partial fraction. Okay, and in this case you are asked to resolve 8x minus 8 all over x squared minus 2x squared minus 8x into partial fractions. And here they decided to give a hint, or in fact they gave 2 hints. Okay, so let me bring out the hints that we have. Okay, so the first one is that they decided to, this thing should be s cubed, not x squared. The first one here is cubed. Okay, so they decided to first of all show you that you can factorize the denominator. Of course, you know that there is x all through, so I can bring out x, and then I'll have x squared minus 2x minus 8. That's exactly what they did. And then they now factorize this bracket to now give x into x minus 4 into x plus 2. So if you do the factorization of this bracket, you will get this. So this is the first hint they gave us, that the denominator is equal to this. I just showed you how they got that. And then the second one is that they showed us the number of fractions that it should have. That's the partial fraction. So that this 8x minus 8 all over that should be equal to a all over x. And where is that coming from? This is the first linear term here. And so that's how you got a over that, plus the second linear term there is x minus 4. And finally, the last linear term there is x plus 2. So this was this is the second hint that you were given here. And then there is actually a third. All right. So, and what is that? The third hint is just a continuation of the process of splitting into partial fractions, which is to get your LCM and all of that. So, but in this case they chose to multiply through with the LCM. So, but we will always do our pattern, which is to get the LCM, and that is x into x minus 4 into x plus 2. Okay, so and when you do that, you are going to have a here. Of course, x will cancel and then these 2 will remain. So a will multiply those 2, x minus 4 and x plus 2. Then plus b, the denominator of b will cancel, and so x and this one will remain. So you have x into x plus 2. And finally, your c will come down and its denominator will cancel. You will have x and x minus 4 left. Okay, so and that's how they produced that other hint that was given in the third part. Let me show you here. Okay, so and what is that? You were now told that your left hand side, which is 8x minus 8, is equal to a, which is the numerator of this. Of course, you got that by cancelling the equal denominators. So you just get a into x minus 4, then x minus 2, plus b into x, and then x plus 2. Sorry, it's not minus 2, it's plus 2 here. Okay, so here you get x and then x plus 2, and finally you get the third part, which is c into x and x minus 4. Okay, so this is the third hint you are given, and then you are now asked to complete the process, and to complete it means to get a, b, and c. All right, so let's quickly do that. To get our a, we can try to eliminate b and c, and to eliminate b and c, all we need to do is to look for a value of x that we cancel them. And if we just make x equal to 0, it will do that for us, because it will multiply your b and c to get them to 0, and we are done. Let 0 multiply 8, you have 0, so you just have minus 8 here is equal to, on the right hand side, if I put x as 0 here, I will have minus 4. If I put x as 0 here, I will just have positive 2, and that's going to give me minus 8 is equal to, on this side you will still have minus 8a, and therefore you are done. A is equal to 1. So you divide both sides by minus 8, and it will give us a as 1, right? So for b, okay, to eliminate, or sorry, to get the value for b, we will try to eliminate a and c. And to eliminate a and c, we will make use of this bracket. X minus 4 is in both a and c. That means I can now make my x to be positive 4. It will help me cancel that. So if I put x as 4, 8 times 4 is 32, and so I have 32 minus 8 is equal to, if I put x as 4 in a, it will turn to 0. If I put it as 4 in c, it will turn to 0. So only in b will I retain something, and that is going to be, if I put x as 4 here, it will be 4b into, if I put x as 4, I'll have 4 plus 2, which is 6. And so 32 minus 8 is going to give me 24. Yeah, and then 4b times 6 will still be 24b. Wow. And then you will get your b to also be equal to what? 1. This is amazing. And then finally, we will try to get our c. And to get our c, the same approach. Look for how to eliminate a and b. And then to do that, you look for a fraction, or sorry, for a bracket that is common to them. And x plus 2 is common to b and a. So, and it means that my x should be equal to minus 2. So I'll put it across. Minus 2 times 8 is minus 16. Then minus 8 is equal to, a will turn to 0, b will turn to 0. My c will become 2c into 2 minus 4 will be minus 2. And so you are here. Minus 16 minus 8 will give us minus 24, equal to 2c times minus 2 is minus 4c. You divide both sides by 4 minus 4, you get that c is equal to 6. Oh my goodness. This is interesting. Very interesting. Okay, so we have gotten our a, b, c. Our a is 1, b is 1, c is 6. So we return back to our original fraction and then substitute there. So let's quickly do that. It's here. Okay, stop moving, mind yourself. So a is 1, so we have 1 over x, plus b is 1, we have 1 all over x minus 4, and finally c is 6, you have 6 all over x plus 2. Of course, you know you write this down, so I'm just showing it here because I already have the fraction there. Okay, so this is just what we have for number 9, and we are done for exercise 9, and that's the last question we have for partial fractions. All right, so the rest is going to continue with permutation and combination, like I said. Okay, do we take a stretching break or we should continue? All right, let's see. Okay, let's see if you are able to run through. Okay, so let's go to another page. All right, so here we want to continue with number 10. Let me see if I can. All right, so for number 10, like I said, is from P and C, permutation and combination. It says, find the number of ways the letter of the word percentage. I'm going to write the word. I won't be writing all the questions here. I will just read for you. Okay, so percentage is the word. Okay, find the number of ways that the letters of this word can be arranged if the is, there are about three is here, if the is in percentage must be next to each other. Wow, this is a very beautiful question. So what are you going to do? Of course, this is from permutation. All right, ordinarily, if you are given a word, let me use, for instance, my name. My name is Precious. Okay, so if you want to get the number of ways you can arrange the letters of my word of the word my name, that's Precious, what do? First of all, we consider the letters of the word, are they different from each other? Like my own is a very beautiful example. No letter was repeated. So for you to get this, all you need to do, just count the number of alphabets there, and I think there are about 8 of them. Just take 8 factorial. That's the solution for the number of ways you can arrange the alphabet of my name. For instance, you have God. God is another example, God. All right, to get the number of ways to arrange this, all the letters are different, so you just have 3 factorials, and that's 6. Okay, so what if you now have repetition? For instance, good. Let's add 0 again there. O. So you have good. There's a repetition of O twice. So to get the number of ways of arranging this is going to be count the number of alphabets, which is 4. So that will be 4 factorial all over. So whenever there's a repetition, you divide by the factorial of the number of times the alphabet repeated. So 0 or O here repeated twice, so that will be 2 factorial. If there is any other alphabet that repeated, you also take the factorial of the number of times it repeated. Let me see if I can get a good example. I have some other nice examples like statistics, mathematics, but do I want to use those ones? Mississippi, those are good ones. Okay, let's use statistics. Statistics. Okay, so here you have about 10 alphabets. 1 2 3 4 5 6 7 8 9 10. Yes, so it's going to be 10 factorials all over. So you now look for repetitions. S repeated 3 times in statistics, that will be all over 3 factorials. You look for another one. T repeated 3 times as well, 3 factorials again. Then I repeated only twice, and that is 2 factorial. So you have 10 factorials all over 3 factorials times 3 factorials times 2 factorials. So that's how to handle the arrangement of the alphabets of a word. Okay, now this one is without condition. There is no condition given, you are just asked to arrange. So but the one we are given in this exercise, there is a condition. And what's the condition? That your letter is must be the same, must be together at each point. So let me give you an instance of what that means. You can have something like P, E, E, E. That's the 3 E's are together. Then R will now come. Then C will come, N will come, T will come, A and G. Okay, so this is one arrangement of such condition that will satisfy the condition we are given in this question. So how do you handle this kind of problem? It's actually very simple. So what do? You will assume that the 3 E's are together. They are tied together as one alphabet. So this is how you go. So you now count the number of alphabets you will get, assuming the 3 E's are tied together. So and that's going to be P1, then the whole E is 2, R 3, C 4, 5, 6, 7, 8. So that's going to be 8 factorials. Then you will check within these 8 alphabets, is there any repetition? You can see no other alphabet repeated here. You are not seeing this E as repetition because you have actually tied them together. So assuming there's a repetition here, then you would have divided by that repetition. So but since there's no repetition, you will now continue. And how do you continue? You will multiply by the permutations of the one you now tied together. And what did we tie together? 3 E's. So that's 3 alphabets, which will be 3 factorials all over. Is there repetition there? Yes. The E repeated itself 3 times. So you divide by another 3 factorials, which means that the 3 will cancel, the 3 factorials will cancel 3 factorials, and your answer is only 8 factorials. Wow. My God. So the solution to number 10 is 8 factorials. And some of you would ask me, is it necessary to expand it? If you have all the time, go ahead and expand. If you don't have all the time, leave it that way. We actually prefer it like this. Okay, so we move on to the next one, number 11. Okay, let me come down here. 11 says another question, but this time around I think it's coming from combination. You are going to see that. It says that a committee of 3 persons is to be constituted from a group of 2 men and 3 women. So the committee has a total number of 3. Total number of the committee is 3. And the chess where you are picking your combinations, you see, that's why I said it's a combination. You know, the pool from where you are supposed to form this committee is made up of 2 men and 3 women. Okay, however, out of these 5 human beings, you only need 3 in that committee. Let's go on. It now says, in how many ways can this be done? So in how many ways can you combine 2 men and 3 women to get a committee of 3 persons? That's beautiful. When it comes to this kind of question, I will always say you need to put up your thinking cap. This is why I love maths. You just have to think and then, reasonable analysis. So what do you do here? If I have 2 women and 3 men, 2 men and 3 women, so there are different ways I can combine them. One can be, I can pick the 2 men and then join them with a woman. That's 2 men and 1 woman. That's one way. Or I can decide to pick just 1 man and 2 women. Okay? Or I can decide to pick no man at all. I will just pick the 3 women because there was no condition. They just said in how many ways. So the committee can just be a committee of only women. It can be a committee of 2 men. And of course, it cannot be a committee of only men because the men are not up to 3. So I hope you are getting the analysis here. So it can be 2 men, the whole of the men present, and 1 woman. It can be a man and 2 women. And the women can also have the upper hand by taking the whole 3 spots. Okay, so these are the 3 possibilities. And so that's the first thing you have to do in this kind of question. You should be able to analyze the possibilities that are available. And then you now try to interpret them in terms of permutation or combination. Now, and what do I tell you that will help you do this? Whenever you see "and" in this kind of analysis, it stands for multiplication. And whenever you see "or," it stands for addition. You can also see this under probability in statistics. Okay, so this is very beautiful. So let's go. The first condition or the first possibility, we said 2 women, me and women. Cut out this place. It says 2 men and 1 woman. So what's the meaning of 2 men? 2 men means you are arranging or you're combining or you're selecting 2 men out of 2. So that means 2 combination 2. Then remember I said that "and" then means multiplication. Then 1 woman means you are selecting 1 out of 3. That is 3 combination 1. And you are done. So just do the same across board. Or here means plus, and then this one man means you're selecting 1 out of 2. That's 2 combination 1 times 2 women means you're selecting 2 out of 3. 3 combination 2. Then or plus then the last one, which is 3 women, you're selecting 3. Actually, we should have actually written that as 0 man and 3 women. But the reason I ignored it is that 0 man will actually give you 1. And 1 times whatever you get will still be the same. So that's why I only wrote 3 women, because whether you write it as 0 men and then 3 women, it will still be the same thing. Because 0 man means you're selecting none out of 2. Okay, so which is 2 combination 0. And 2 combination 0 is 1. In fact, anything combination 0 is 1. Okay, so we can actually write that 2 combination 0 multiplied by 3 women now means 3 combination 3. And funny enough, 3 combination 3 is also 1. Because I think I noted that, okay, that was in class. Now, whenever you have n combination n, that's 10 combination 10, 100 combination 100, whatever, is always equal to 1. And it's also the same thing as n combination 0. If you have any number, no matter the size, 1 million combination 0 is always equal to 1. Okay, so let's move on. So what is 2 combination 2 from what I just said now is equal to 1. So you have 1 times, what is 3 combination 3? Meanwhile, what is combination? N combination r, the formula is n factorials all over n minus r factorial multiplied by r factorial. Beautiful. So that you will see how 2 combination 2 will give you 1. So 2 combination 2 is going to be equal to 2 factorials all over 2 minus 2, which is 0 factorials, then multiplied by 2 factorials. So you just see that 2 up will cancel the 2 down, and you only have 0 factorial down, and 0 factorial is 1. So you have 1 over 1, that is equal to 1. Okay, so haven't seen that. We will now need to do for 3 combination 1. What is 3 combination 1? That's 3 factorials all over 3 minus 1, which is 2 factorials multiplied by 1 factorial. And that's going to give us 3 factorials is 6. 2 factorials is 2. And that's equal to 6 over 2, which is 3. Meanwhile, you know that factorial means, for instance, 3 factorial means 3 times 2 times 1. Okay, so just like that. I didn't bother with all of that because I believe that you should know. Okay, so let me remove here. Alright, so that's beautiful. So we got that 3 combination 1 is 2. So you close this bracket. Then plus, here you now have 2 combination 1, which is also equal to 2. Let's look at it. 2 combination 1 is 2 factorials all over 2 minus 1, which is 1. Then multiply by 1 factorial. So that's going to give you 2. Then times, sorry, did we get 2 here or 3? I thought it was 3. We got 6 factorials all over 2 factorials, which is 3, not 2. Sorry. Okay, so this was 3. Okay, and then 3 combination 2 will also be equal to 3. How did I get that? There is what we call complementary combination. Okay, so that concept says that if I have n combination r, that it is equal to n combination n minus r. I'll use an example. What it's saying is that if I have 7 combination 2, that is the same thing as 7 combination 7 minus 2, which is 5. So if I have 10 combination 3, is the same thing as 10 combination 7. So just subtract the initial r from your n, it will be the same thing. Okay, so and if you look at that, you see that 3 combination 1 will now be equal to 3 combination 2. So since we got 3 combination 1 as 3, Therefore, 3 combination 2 will also be 3. You see, all of these small remarks that I'm giving you, that's actually what makes combination journey a beautiful one. If not, you would have to simplify a lot of things. But if you know all of these remarks, it makes work easy. Like this last bracket, 2 combination 0, you know is 1. You don't need to simplify it or to start expanding it. You already know that any number combination 0 is 1. And then this other one, 3 combination 3, is also 1, because any number combination itself will as well give you 1. And you are done. 1 times 3 is 3, plus 2 times 3 is 6, plus 1 times 1 is 1. And your answer is what? 10. Okay, so please pay attention. This particular question I just solved now is actually in 2 parts. The first is what we just finished. The question says a committee of 3 persons is to be constituted from a group of 2 men and 3 women. In how many ways can this be done? That's one question. But I discovered that most students, when they solve this exercise, they leave this part and go straight to the second question. The second question now said, how many of these committees would consist of 1 man and 2 women? So notice that the first question is actually there, which is what we just finished doing. So you don't run and leave that one and only do the other one. You get half mark, of the total. Okay, so let me assume that that is my A. Okay, and then this other second part should be my B. All right, so and what is that? There they said in how many of these committees will consist of 1 man and 2 women. And if you go up where we analyzed the whole possibilities, you see that this last question is actually there. That's why in maths, if you follow the process, you see that sometimes your answers are even in the questions that you are given. Okay, so the middle one was where we picked 1 man and 2 women, and that middle one gave us so you can just write it here, 1 man and 2 women. Okay, so and that 1 man and 2 women was 2 combination 1 times 3 combination 2, and we got it as 2 times 3, which is equal to 6. Okay, so that makes you can discover that the first question made the second very simple. All right, and that is that for number 11. For number 11, okay. Should we fire on? Let's fire on. Remember, like I said previously, that the part 2, which you people call module 2, has about 19 questions, and we have done up to 11, and we have we did 1 to 6 in the pre-recorded video, and here we have done 7, 8, 9, 10, 11. All right, so we have 12, 13, 14, 15, 16, and so on left. Okay, let's try to finish the permutation questions, and that is up to number 14. And then maybe we will take a small break and then finish the remaining ones. Okay, so we go to number 12. Okay, so for number 12, a group consists of 4 girls and 7 boys. Okay, number of girls 4. Let me write it out. Number of girls 4. Number of boys 7. Okay, and then they said in how many ways, it's just like the previous question, in how many ways can a team of 5 members be selected if the team has, so they started this one by giving you the condition, just like they asked in the second part of number 11, where they said 1 man and 2 women. So this other one started with those conditions immediately. Excuse me. Right, so let's go on. So what is that going to be? The first one says if no girls will be in the committee. Okay, so if the committee is team, sorry. So in how many ways can a team of 5 members be selected if the team has no girls? Alright, so very simple. If the team has no girls, then it means that all the 5 are being selected from the boys. So that's going to be 7 combination 5. So you're selecting 5 out of 7 persons. And that is very easy. That is 7 factorial all over 7 minus 5, which is 2, then multiply by 5 factorials. So all you need to do is to simplify this, and that's going to give you 7 times 6 times 5 factorials. Why did I stop there? Because I have 5 factorial in the denominator, so 2 of them can cancel out. So what is 2 factorials? That is 2 times 1, which is 2, then times 5 factorial. So you can see these 2 will go away. 2 will cancel 6 to give me 3, and 7 times 3 is 21. So there will be 21 ways of selecting 5 boys out of 7 boys. This is why coaching work in football is very difficult. You have to select 11 out of 24 team members. So you can see the tedious job you have to do there. This one, you are just selecting only 5 out of 7, and there is 21 ways. Jesus, that's a lot of ways. That's why to do maths is good. You know what you expect in different jobs that you want to do. Let's go on. The B part, they said if the team will have at least 1 boy and 1 girl. I think I like this one. At least 1 boy and 1 girl. Okay, so what is going to happen here? All right, so I am looking for 5 persons, but then here we need at least in that 5 there should be a boy and there should be a girl. So just like we did in number 11, you are going to bring out all the possibilities here. So if I need 5 persons and there must be a boy and a girl, so the possibility can be a boy, 1 boy, and the girls are up to 4, so I can have 1 boy and 4 girls, or I can have 2 boys and 3 girls, or I can have 3 boys and 2 girls, or I can have 4 boys and 1 girl. You know I can actually have 5 boys because the boys are up to 5, up to 7. But the question here says there must be at least 1 girl and 1 boy. So I can't go further from here. So these are all the possibilities that you can have, and then you are done. So try to now simplify what you have. 1 boy means 1 out of 7, that's 7 combination 1, times 4 girls means 4 out of 4. Then you close here, plus 2 boys means 2 out of 7, times 3 girls, 3 out of 4, plus 3 boys, 3 out of 7, times 2 girls, 2 out of 4, plus 4 boys, 4 out of 7, times 1 girl, 1 out of 4. My goodness. Okay, so and you are done. So you now try to simplify all of these. You try to simplify. So if you do this simplification, blah blah blah, whatever, you already know how to simplify all your combinations. We don't have the time to be writing all of this. So this is going to give you 441 from my own calculation. I think that's what I got. I hope that's going to be correct. So just do your 7 combination 1, 4 combination 4 is already 1, and so on and so forth. So you should get 441. Okay, so we move over to number 12C. So there the question says, what if the team has at least 3 girls? At least 3 girls. And you can come up here and see, you see, that's the beauty of this thing. You can come up here and look at the possibilities where you had at least 3 girls. And what are the possibilities? You know, at least means it can be 3 or above 3. So here you will see, excuse me, just a minute. Victory belongs to Jesus. You enjoying my song, Abby? Okay. Don't mention. Let's go back to work. Okay. So, at least 3 girls means you can have 3 girls or above 3 girls. And you actually have only 4. So, that means it can be 3 girls or 4 girls. And there are just the 2 possibilities that we first wrote here. And so, that is going to give us a boy and 4 girls, or 2 boys and 3 girls. So these are just the only 2 possibilities you will get if you need at least 3 girls. And so that's going to be 7 combination 1 times 4 combination 4, which is 4 girls, plus here will be 7 combination 2 times 4 combination 3. Okay, let's try to simplify this one. All right, since I left the other one. So this is going to be 7 factorials all over 7 minus 1 is 6, then times 1 factorial, multiplied by 4 combination 4 is 1. I don't need to expand that one. Then this is plus, in this other bracket I have 7 combination 2, which is going to be 7 factorials all over 7 minus 2 is 5, then multiplied by 2 factorials, then this is times 4 combination 3, which is 4 factorials all over 4 minus 3 is 1, multiplied by 3 factorials. So this is going to give you 4. Okay, so let's go. So what is 7 factorial all over? Of course, 1 factorial is 1. So this is going to give you 7 times 6 factorial. So 6 factorial will cancel the 1 below. So you just have 7 times 1, which is 7, plus. So in this other bracket, here you will have, let me try to expand that one. 7 times 6 times 5. Okay, I think we got 21 in this. So you just have 5 factorial times 2 here. This will cancel this. This here will give you 3. Yes, we got 21 here. Okay, let me not close this. So this will be times 4 factorial all over 3 is going to give you 4 times 3 factorial. So 3 factorial will cancel 3 and you just have 4 here. I hope that is making sense. So, and that is going to give you 7 plus. So here you have 21 times 4, which is 84, if I am correct. Yes, 84. And 7 plus 84 is 91. Okay, so there are 91 ways that you can get at least 3 girls. Okay, and that is the last question for number 12. Okay, so and then we now move over to number 13. I hope you are following me. I hope you are with me. Right? So let's see. For number 13, let me see if I can do that here in this small space before going to a new page. Okay, so it says the same question from the same permutation and combination. We are told that from a bag containing 7 black balls and 5 white balls, how many sets of 5 balls, of which 3 are black and 2 are white, can be drawn? Okay, so this one is just straightforward. So you are given 7 black balls and you need a total of 5 balls. Okay, and in that 5 balls you want 3 to be black. So that means you're selecting 3 black out of 7 black. So let's just go ahead straight away. So that is 7 combination 3, and you are now selecting 2 white out of 5 white. So, and that is 5 combination 2. You are done. Nothing else. That's all. So, and what is the meaning of and? Remember I told you it's multiplication. So this is going to give us 7 combination 3 is 7 factorials all over 7 minus 3, which is 4, multiplied by 3 factorial, then times, here will now be 5 factorials all over 5 minus 2 is 3 factorials multiplied by 2. Okay, so let's try to finish that here. Okay, we can simplify this to 7 times 6 times 5 times 4. So the 4 factorial will cancel this one here, so I'm not going to write it. All over 3 factorials is 6, so 6 will cancel 6 here. Then times, let's come over to this one. I can expand this one to 5 times 4, then times 3 factorial, and that 3 will cancel this one, so no need writing it. And your 2 factorials is 2. Okay, so here 4 will cancel 2, 2 will cancel 4, and you will have 2 left. Okay, so which is going to give us 7 times 5 is going to be 35. And so you have 35 times 5 times 2 is 10. So 35 times 10 will give us 350 possible selections. That's what you're going to have in number 13. So it's just very straightforward. Okay, so let's go again to another page for our number 14, which happens to be the last question on permutation and combination. All right, so what is the question? It says, find out the distinct 4-letter words that can be formed from the word Singapore. Singapore. Let's write it. Singapore is a name of a country in Asia, if I am correct. Okay, don't mind me, it's maths I did, not geography. Okay, but I think I'm correct. Okay, so how many distinct 4-letter words can be formed from this? Now, if you notice, you see that this particular word here, Singapore, also has distinct alphabets, and the number of alphabets here is this is 4 is 9. Okay, so just as I told you that for instance, if you have, let me use this example to explain this. If you have let's say a bus of a 14-seater bus, and you have 5 persons to arrange inside that 14-seater bus, so what you want to do is, how many ways can you arrange 5 persons inside a 14-seater bus? Okay, yeah, find out the 4 distinct ways. So you are looking for the number of ways you can arrange 5 persons in a 14-seater bus. Now, but in this one now is a combination. How many ways can you combine a 4 distinct letter word? So for instance, if it is arrangement, you know that when they are different, or as in, let's say I have P-O-R, for instance, P-O-R-E, that's poor, from Singapore. Now, even if I rearrange it and I get P-O-E-R, okay, so it is still the same letters. So in combining these, I have not changed anything. So, but if it is arrangement, then they will mean different things. So assuming you are looking for arrangement here, this would have just given you 9 permutation 4. So you are looking for the different ways you can arrange 4-letter words out of 9. But here you are just combining. So whether you combine it as P-O-R-E or as P-O-E-R, it will still be the same distinct words or distinct letters, sorry. So in other words, this is going to be a combination. So you just have 9 combination 4, and which is going to be 9 factorial all over 9 minus 4 is 5, then multiplied by 4 factorials. And what is that going to give you? You try to expand 9 times 8 times 7 times 6 times 5 factorial. Okay, because I have 5 below, so I have 5 factorial times 4 factorials is 4 times 3 times 2 times 1. You can leave the 1 out because it will still be the same. So 5 factorial will cancel 5 factorials. 3 times 2 is 6. It will cancel this 6. 4 will cancel 8 to give us 2. So finally we have 9 times 2 times 7. 9 times 2 is 18. And 18 times 7 is going to give us about 126. And that is the solution to number 14. And that's where we are going to end for this other part or this section of part 2. I wanted us to finish it down to number 19, which is the last question. However, should I finish this? Okay, let's take a break. We will come back after a few minutes. All right, have a very nice time for those of you who followed. Bye.